on a session which is going to be slightly different from whatever we've had in the past, because this is basically on the application of whatever we have learned into real life problems and how we can use these concepts to actually solve uh, the details of a problem. In this case, the area is NLG, or natural language generation, and the application that we're talking about is basically dialogue, especially a negotiation dialogue which has strategic implications to it. So with the application that the technologies that this application would be using will be mainly deep learning and deep RL. The concept is basically to use these two technologies to be able to give a more efficient and a more meaningful strategic dialogue with a human uh, feeling to it. Because initially we just go through what the original thing is now, or maybe a little earlier, how it all started and how things have evolved. So this strategy that they're talking about is hierarchical text generation and planning strategical dialogue. So this is basically a fact where they are saying that when we are in a dialogue, then there are multiple types of dialogue you have. You have assistive, and you have, say, something like customer service. You have, now these are all, I think they have their initiation from the chatbots that are there. Now this is beyond that, where we are actually using. So this has come from the dialogues that were there were basically this. Then we have a dialogue where we are negotiating. Two agents are complete. So there is one computer and there is one person on the other side. They're negotiating a deal. So previously, what people used to do was they used to have uh, different types of mainly chat boxes and early sequence to sequence dialogue papers. This is how it was there previously. Now, once AI came in, then people started using some part of it, like training sequence to sequence systems for standard, this thing, use of reinforcement learning and RL based. And so the problem was that when we were using RL, or when we were using these technologies which were just used without too much of thought in it, the people were, the language of the whole chat box or the response from the machine became such that the very English became subsidiary to that. So we thought that uh, we should improve that. And initially, the dialogue which uses RL, which is the core of this solution, was that the way that it is there, that you had multiple rollouts that were there, and it was simulated environment, and RL was supposed to get the maximum amount of it. But the problem here was again that the language, the English language, got compromised. So the the challenges that in general text generation had was, as you see here, lack of semantic diversity. Same where answers used to be coming in for multiple dialogues, and there was a problem where the context got lost. There was linguistic diversity that got lost, neutral, and there are lots of things like, okay, thank you, yeah, this can happen, this. So the blend of answers from the machine when it came, it became very uninteresting, and there was a lack of coherence. So these were some of the problem areas that is tried to be addressed in this specific use case. And again, the generic use of reinforcement learning. The main compromise was that the language got compromised, the end-to-end model uh, Dialog are challenged to train. It's a huge challenge to train them. So just taking one piece of technology to answer a major question was getting very, very difficult. So now what happened was in 2018, this Yates gentleman, he came up with a very uh, different thought. He says that, okay, we are giving utterances in terms of whatever we are inputting to the dialog box, and that is only what the person wants to say in that specific time. So if he types in a message xt, and the response, if it is just to that query, then especially for negotiations, it becomes very difficult. So what he did was he uh, divided the whole problem into two things. One was linguistic, and the other one semantic. So what he said is semantics would be handled by RL, and the linguistic part would be handled differently. Now he said, look, what we are trying to do is, because it's a strategic dialogue, we are more interested in what is the content of the query. What is it that this person actually wants to ask? So there was a question of how to have a history of context built into the solution. So he said that, okay, well, first let's divide this into two things. There is this concept of latent variable, discrete latent variable, where you have divided the whatever the question has been asked, the message that comes in xt, that has to go through a process which uses this fact of discrete latent variable. Now, this discrete latent variable actually tries to uh, get the context or the actual core of the question message, rather than the actual semantic, the actual uh, words that he's saying. So he divided that, and he said that XT is to be learned to be a good predictor of future events in the dialogue. Now, what happens, like I said, is usually dialogue chats became very boring, and it was out of context. So now, if we have to make a strategic dialogue to last long and to still take the context with it, this was the concept that was used, that we will have two parts of it. One is the actual message, and one is the intent of the message. The intent of the message was taken as XT, a set of responses which would correspond to the previous intent and to take it forward. So this means that Z learns to represent XT's effect on the dialogue and not the words of XT. That the word of the message is something, but we need to know the intent or the effect of the message that XT is trying to give. Thus, XT separates strategic aspect of the task from the emergency aspect. This is very useful for controllability, interpretability, and easier to learn the study. Now, here what is happening is the RL is actually learning how to create the dialogue, rather than just facilitating the semantics or some part of it, which is the word-to-word representation. So the approach that is overall approach that is there is to use a method of learning that is decoupling the semantics of the dialogue utterances from its linguistic approach, use latent sentence XT for hierarchical generation, planning, and reinforcement learning, then improve the ability of the model to plan ahead. Now, this concept of this part of RL, which we can use to plan ahead, is what is getting used here. So that's why this class I'm trying to give you options in which how for applications, the technology that we already know, for application, how do we look at using each of the technologies and to fine tune the solution as per the requirement. So in this case, the aspect of planning and uh, learning of reinforcement learning, that part of is it getting used, improve the ability of the this thing to plan ahead to create a set of semantic diverse candidate messages by sampling. So what is happening is you are at the end after each state, after each time the XT comes in, you have n number of different intent messages in ZT. ZT is a set of candidate messages that you can use, and then use the rollout to identify an expected reward for each. RL is applied in learning based on end task. So what it's basically doing is we are using RL only for actually the strategy part of it, where we are abstracting the linguistic part, we are abstracting all the other uh, parameters of the dialogue that is happening to only the parameter which actually deals with a deal being made or not made. And that is where RL is getting, uh, gives you the advantage of fine tuning. So advantages is end-to-end reward achievement. I will show you this thing a little. Here, if you look at it, this is the diagrammatic this thing of what I was saying.
Salim, there was
We
a
have some.
question on the previous slide. How do
Okay, just a
you
minute.
define the end task in a dialogue? You can read the question yourself as well.
Hmm, how
In the
can you?
question mark. Yeah.
Yeah, how do you define the end task? In the end task basically is that either the dialogue is, I mean, either the deal is made or not made. If the your message says that it in as a deal is done, then you give but reward that the agent gets is both the agents will get. In this case, it is the two agents playing each other. As we go, we'll show you that. For training this, what we are doing is we are training the agent by playing itself. So the agent only gets a positive reward once the deal is done. Till the deal is not done, there is no reward for either of the agents. This is for the training part of it. Okay. So anything on this slide? Create a set of, this is dialogue semantic, then create a set of latent sentences ZT consisting of semantically diverse candidates. See, what is happening is that sometimes our answers seem to be very similar to what we have answered before in terms of the language. So what this also tries to do is that it wants various different types of diverse candidate messages giving the same semantic message but differently said. So how and what is differentiated? So the how part of it is taken care of by the ZT, and rather ZT gives what, and the different variations of ZT is how. And then you say the rollout to identify the and you have each rollout to identify whether this is going to actually end in a deal being done or not done. So this the goal of RL is to make the deal, make it a done deal. Now, who wins or loses doesn't matter. In this case, for trading and this is the objective of that. Like I said, ZT is giving you a set of outputs which are semantically the same what their this thing is collected. This is what we're doing is we're using a clustering model for this. So you have n number of responses from this module, which is the clustering module. And if you look at the details here, we pre-train a model to learn discrete encoder for sentences with bottlenecks of xt through discrete representation. The architecture forces ZT to capture most relevant aspects of xt for predicting the future messages and actions. See, the main thing here, what they're trying to do is they want to make sure that the dialogue continues and the context does not get lost because of the response that the person does. Maybe so, it may be like this also, or something like that. If he says, then maybe the machine may not be able to understand exactly what it means. So these kind of responses are filtered in a way to make it more coherent. We then extract the discrete representation, which is marked in the okay, which is this area in the orange state, that is px, that is the probability of zt, how this is getting done. Is this clear? Is
I think
this
there was a
slide
question.
clear?
There
Mhm.
was a question in the questions tab, if you can check.
Just a minute. Is it divide?
Now, how do you divide
How the
semantic
semantic
and linguistic part?
yeah, that's what I was just trying. Yes, it is dividing. Oh my god, what happened? Yeah. So this is dividing. One thing is that there are two level hierarchy, right? So in the first level of filtering, you are doing you are getting a set of candidate ZT messages, which are more coherent messages uh, for the same message that XT wants to give. They are clustered in different basket, and once this is done, then this cluster, the highest probability one, is fed into another model, which is the full model on the left. I'll just take you in the details of this. This was just so the text generation sequence, the way it goes is the text is generated as a sequence. Use the agent first samples short-term plan to form the latent signature. That's the first, the in the previous one, the left side, this clustering model is getting used. The set conditions this plan during generation, allowing precise and consistent generation of text to achieve a short-term goal. Okay, so the short-term one is done and the first. Doing so, we disentangle the concept of what to say to how to say it. So what to say is our focus. How to say it is what comes out of the clustering. To do this, we include the method of learning discrete latent sentence based on their effect on the continuation of the dialogue. Now, this is decided to see which of the ones of how to say it should be used so that the dialogue is continued. So this is how the whole concept was. Now the latent variable is inferred to be maximum likelihood of a message given the previous messages. Like I said, the context is kind of carried on till the next messages. Latent variable xt is optimized to maximize the likelihood of this actions and continuation of a dialogue, but not the message itself. Again, we are re-emphasizing what has been said before, that the whole solution is to make sure that the context and the strategy of the dialogue is continued across a number of messages and the core is captured. The distinction is more important because with similar words can be very different semantics. Conversely, the same meaning can be conveyed. So that's exactly what we've been saying. A result on how empirical human this thing is, both better in terms of, now what they're saying is using this hierarchical way of kind of processing this data, this makes it very close to what we have when we are talking to humans. Qualitatively, the representation is more semantic, coherent, and linguistically diverse. Again, This is in the context that the dialogue has to continue in terms of its strategy without getting lost in words and sentences. Using message representation improves the strategic decision making of our dialogue. So this basically, like I said, the focus is on strategic decisions, and these are the ground rules that are there. This is the agent and the X. I'll just show you this. This might give you. So this is the dialogue where the action space is the dialogue space, where it has X and Y agents. Each agent has a value function, which is very different from each other. They do not see each other. If you look at this part, the agent X and Y have a space. They have different value functions. It cannot directly observe each other's this thing. And the agents sequentially exchange terms of natural language xt consisting of n plus 1 this thing till one agent enters a special turn that ends the dialogue. Like I said, the dialogue only ends at a deal done or not done. Deal done is when you say as long as the deal is not done, the dialogue continues, then the deal is done. Once the deal is done, each of the these things gets agents gets a positive value, which I think you will see here. That as long as the agents are in the action space, x1, ax1, ax2, ax3, this is the action of the agent x, and ay1, ay2, these are the actions of. So they are exchanging dialogues. Till that time, there is no reward to either of the agents. Only once the agreement is made, then there is a reward for each of them. So this is how the thing works. Now, what happens is that there is an action classifier. Once the agent has the dialogue has been made, then the classification of whether the deal is done or not done is taken care of by the action classifier. You train the action classifier. This is a RNN, this is a deep learning, this thing which actually is more of data consolidation and pattern kind of thing. So this is what the classifier does, is encode the set of, oh, just a minute, I have another question. What is the basis? Latent sentences is on what basis the days? It is basically it is decided on two things. On the context that was there previously, I think this will answer the question. This will answer the query. What happens now?
So Salim, we are using reinforcement learning for
Yes, there
optimizing
are two
dialogues,
parts.
right?
Yes, the dialogue person is using the reinforcement learning, but then there is this classifier which is getting used, which is the RNN one.
Okay.
So encode the possible actions. So what it is doing is it is giving the inputs to the reinforcement learning. It is encoding all the possible actions, say Q with this one of the agents, MLP is a multi this one perceptron or this thing. So that is one RNN that is there, and each of the sentence and each sentence xt as. Now this there is a concept of embedding, word embeddings that is being used across encoder decoder, so that you can kind of support the dialogue uh, scope. Basically, when you are embedding word, embeddings are used, then you are giving it a constraint on what the dialogue has to go through. So this is how it is being done here. And there is a loss function that makes sure that the likelihood of this function is possible to this. Make sense? Okay. So this is how the action.
There were some other questions as well.
Yeah, I think the other questions I would want to take it up a little later.
Sure.
Okay, what is the basis of basic of that's what I said. The basis basically is how what is the basis of latent sentence is decided. The basis is basically two things: how coherent is it to the pre-existing dialogue, and whether it is ending in either a deal or no deal. Is the deal in
What
your
is
example?
what is the deal?
Deal basically means that this is, see, a strategic dialogue where you are saying, oh, I think I'll just go to the, just a minute, oh, just a minute, let me go back. Here, here if you see this action space, there is a dialogue going on saying, actually this is the action space where the dialogue is going on. There are two people. One trucker says that he has, there are set of balls that are there and there's a hat. They have to come to a decision on who gets what. So each one says like, okay, I want so many number of hats. So this guy says, I want hats and book. Or so that dialogue that is going on is basically on coming to a conclusion that there is a decision that has to be made on division of hats and caps, and the dialogue has to decide on who gets what. Till that time that this is decided that okay, agent X gets hats, or agent X and Y both are satisfied with what they get, then the dialogue ends. Till the time that they are still negotiating, the action space is there and there is no reward being given to anyone. So the deal is done only once the decision is made on who gets what and both of them agree to it. Does that answer it? I think I have just lost one slide, which is
Yeah,
why this.
yeah. No, it answers that.
Is there a deal example? Okay, I think I tried to give it to you. I'm sorry, I that got lost in this. How do is positive or that is not, see, whether the deal is positive or negative is not what we are looking at. What we are looking at is, can the deal be made or not. This is just to train the this thing agent. So the agent has to be trained on getting a deal done. Whether it is positive or negative will be taken care by the classifier. What is the data set? Those details I will have in the next session, where we will actually go through the code and the actual use case. This session is basically to get the concept clear. In the next session, we'll go into the code and actual showing you what the details are in terms of the each of the models and how they are done, what is the uh, uh, details of how the this negotiation has actually taken place. But I would want to do it in the next session, because I thought if doing both of them together would confuse everyone. It's a huge topic, and I would want to give it in two sessions. So yes, the data set and all we have used, and this is a running code there, but we'll discuss about it in the next session. Is it possible to run two or more negotiations or two? At the moment, it is only for one. But yes, you can do it. But this specific case is for one, and also this presentation is to give you the concept of how we can use our technology of reinforcement learning and deep learning into solving problems, and the way these problems, the solution can be factored, or the concept level on which the solutions can be factored. The coding can happen a little later, but this is the way, the concept level, how the solution is arrived at. Okay, so this is it okay? Can we come back?
Yeah.
Now
Continue.
the action, yeah, the action classifier. This is the flow chart for that. give me a book and a hat. He says, take one book. So now how this is going through, this is how this action classifier is working. Who's winning, who's losing, this guy is taking care of that. When the action classifiers, this thing policies pi, and in the action space at x0 to 20, the number of options that it has, which predicts the distribution over action using GRU with attention. So this is RNN in this case with attention. Now, this baseline hierarchy model is one model that they have created to train the hierarchy model encoder decoder model to maximize the likelihood of the training dialogue sentences. Someone was asking about how the training dialogues were being trained. This is how it is being done. The model trains action value encoder to input the action space A and the value V. So value function is for each of them is different. And value function, like we know in case of reinforcement learning, is the value of your value, the value of the agent has when it is in a certain position. So that value function is different from both the agents X and Y, and they are fighting with each other to come to a conclusion. The sentence level encoder that reads sentence embeddings, like I said, they're using embedding in this case to constrain the uh, scope of this, and the action space encoding to produce dialogue state ST. The encoder decoder share a word embedded matrix this, and they minimize the loss using the normal loss function that we have. This is how the hierarchical model looks like. These are the two agents. This give me two hats. This one says this. Now you'll see here that this is happening in T, and the response is coming in T plus 1. And this is how we are capturing the dialogue. Okay. Now the concept of learning latent message. So this is the core behind it. How do we learn this latent message representation? I think that was asked a little earlier also. The focus of our is to encode XT as discrete. The goal is to learn the message representation that reflects the effect of the message on the dialogue while abstracting the semantics equivalent paraphrases. So what is said is more important than how it is said, and the how part is getting uh, separated from the what, the discrete later, and whatever is connected to closest to what is being said, the how paraphrase closest to that is being used. The discrete latent variable allows us to efficiently make sequential decisions by choosing xt for each step to govern the outcome of. So at each step, for each xt there is a zt, and the zt is containing everything before st in terms of context and in terms of the value to the dialogue, and after each step this is how it is. This approach is helpful for planning and reinforcement learning. We use expectation maximization to learn how to assign messages to cluster to maximum likelihood to future messages. See, again, the focus is how to carry on the dialogue. The messages, whatever is getting fed into it, they have to be kind of processed in a way that the dialogue continues till the logical conclusion, which is basically deal done. The difference in approach is that the message embedded ET is used as input for stochastic node PZ. PZ is that this thing which at xt, that zt, not here it is not the x, it is z. That is the context of this, the list of zt over the action space of a and coming from the message xt formed by softmax for parameters EQ over the latent state xt. Does that answer the question? Just a minute, I have another question. Oh, that is any of these DLLs basically. In this case, it is RNN. And RNN, like I said, is the classifier. It is getting used in as a classifier. I hope that answers the question. Now we have gone into details of how this is being done. That is the clustering module. You have give me 2 and this guy says this. So this is how we have come to a conclusion that there is a probability of action AT, which is this, and take 1. That is the output that we are getting from the clustering. So take 1 is is actually the content that is there. Now the semantics could be different so it will have a set of a number of semantics for this, and for X, and this is for Y. Here RL is getting used as self-play, in the self-play mode. It does not have any trained data from beforehand. And then we say, okay, now again, we are talking about text generation. So we train a new hierarchical model X, which uses retrained representation of xt star to predict messages, which is xt. First, we train RNN to predict px this. This is the first training that happens. Then px learns to translate xt into fluent text in context. So that is where you get the clusters. Optimize the model of predicted px into this to maximize the marginal likelihood of training sentences. Makes sense? So this is how actually hierarchical text generation is happening. So everything here is basically they're trying to make it hierarchical or sequential. Mainly there are steps in which you go to this level and then to this level, starting from top to bottom. So each of them, so that's what I feel that this hierarchical method of doing various things is what we could use in our projects when we are trying to solve problems, rather than to make it too complex. Break it up into different hierarchy levels, address it like that, and go to the next level. That's what I found this paper very useful for. Now, once you have done the clustering, then this is coming here to the next level, and the final solution for the model is coming from here, where after all the processing of the clustering, you have n number of options here. You take only one here, and that is being given to the dialog box. Now take one and then OK, deal. So this is now the deal is done, and now you go to the inference part, where your action, this one takes over, action classifier, and then closes the deal. There is
So Salim, we are using policy-based RL here, right?
we are
Policy learning.
using, yes, definitely. It's all policy based, not really policy based. This is basically you are using your, yeah, it's policy based, but you're also using the off policy part of it, because you're using a lot of rollouts, right? So the rollouts basically means that they have gone there before and then coming. Yes, it is through policy only.
So we don't have value-based, also called Q learning, going on. DQN.
Value functions are there getting used, but not because for each state you need to know where the agent is in terms of his value function. Is he
Is
close
it
to it?
continuous action space or discrete action space?
Discrete actions.
Okay, okay.
Because this xt is a discrete. For every xt there is a zt, a set of zt's.
So the output actions are limited. They are not infinite actions.
No, they are not infinite. And
Okay.
also, because they have embeddings and they are using encoding and decoding, it is still limiting them to even more.
See, we have these text chatbots, let's say for
Hmm.
railway booking or airline
Hmm.
booking,
Hmm.
right? We have text chatbots or messenger chatbots. So they are based on rules-based chatbots, but I think this allows us to do AI-based chatbots, right?
Yes,
Where
AI-based chatbots, and the main thing here is that it is open. The agent is learning as it is moving whether the deal is going to be done or not done. It is it learns from the various inputs that it is getting, that it is not getting carried away with the language part of it, or it is not getting carried away with the fact that the message is not clear whether it is yes or no. It is a strategic decision that has to be made. So the context always needs to be on the top of the message, the interaction that is going on. So whatever the message the agent is giving, it has to be given to the other agent in the fact that this is the purpose, or this is what we've been discussing, and in during this discussion, either it is a yes or it is a no. So the rules are getting made as the discussion is following. So the agent is learning as the dialogue is going on. If you see the conditional language model, because that is also very important. Train xt with zt, this thing. Text generation does not condition explicitly the agent value. This all knowledge and goals and available actions is bottled through the dialog state. Now, what is happening in one more in this RL? What happens is if you give too many inputs, then to go to the next step or to cross to the next step, it confuses. So that's what the linguistic and the semantics of even text. There is only one aspect of it, deal done or not done, that needs to be predicted and needs to be ignored. So, in the sense where only one of the parameters goes is given to this thing, that the latent variable prediction model. This part of the model is what is getting tracked and fine-tuned by RL. And the decoding, again, we are using readers model to generate a first sample and like I said, the main thing was that we were only taking PZ to RL to get it tuned to the fact that it gets it learns. Why is this? Yeah, so this is hierarchical reinforcement learning and exactly how hierarchy is used in reinforcement learning. So is this visible now? Vivek?
yes, all good.
Yeah,
All good.
okay.
Yes.
So the approach is to get pre-trained model from this. The model engages in a dialogue with another model. In this case, there are two agents that are there. The reward is then back propagated to the policy gradients and fill all the model parameters except the parameters of predicting PZ. That's what I said. We have just taken the parameters which are used to predict PZ. This allows the reinforcement learning to improve the decision about what to say without affecting the language generation. So this whole concept of being able to use reinforcement learning to get a specific goal is what I feel we could use uh, our technology in. This also takes care of the issues earlier while using RL in language. This is avoidance, divergence from human language. Now, if we had given the whole model to RL, and with all the parameters, then this would happen, and overcome the challenge of adversely affecting the quality of generated language because of model parameters governing both strategic and linguistic aspects. So that we have uh, this thing divided it into this. Linguistic, we've taken it off. Only strategic we are taking using reinforcement learning for. The rest of it is being done by the RNN. And just a minute. And then similarly, while planning, hierarchical planning we're talking about case sets of candidate messages that XT has XT1, XT1, XT during XT, XT1, XT2, XT3 are sampled from PX. That is, when the whatever XT is given, it is now sampled for PX, I mean, and then the multiple rollout for future dialogues are sampled from the model. Again, we are using rollout to get multiple uh, candidate options to be fed into ZT, so that you can outcome are scores according to the value function to estimate the expected reward. And this we are using now RL in a different way here, where you're looking at for each rollout, what is the value function that is getting done, and then the expectation is approximately n samples. This part I will show you in the next part of our presentation, where we actually go into details of the code. Here in this example, they have used 1,000 samples for each. And so how they have used it, what is it used, that I will show you once we go to the next level, where we are talking about the actual program and the actual solution that they have done. This was mainly to give you the concept of this is what you will expect in the code. Solving the problem, multiple candidates, paraphrasing the same intent, hence the same thing we've already talked about this before. So this was basically my intent. We estimate the reward of the candidate message choosing the best option. So that's all that I have. Thank you. Any other questions that is there? These are the
Okay, that's
references.
it. Audience, any questions?
Okay, let me see.
Now, which course this is under, Salim, in Stanford? What course is this? Is it NLP course or NLG as a separate course, or what?
NLP course with dialogues, and
Okay.
this was basically part of this thing for the strategic dialogue. But then there was a paper that it referred to, which is what I have used here. So this was one of the papers referred to in the Stanford presentations on NLG, and the specific paper that was there was basically on hierarchical decision making using RL in this. And I thought that this would be another variation, like you wanted us to be the superstars. So this is one area where we need to be focusing in, that you have the technology, you have the problem, you need to make the two things together, and you need to use which part of the technology to be used to solve what kind of problems. So I thought that this strategic dialogue was a very simple use case of a very complicated technology that they're trying to use. But I think we can break it and use it in pieces for various kinds of problems that we are solving technology-wise. Would that make sense?
Yeah, there are some questions on questions if you check.
No, I don't see it here. Just a minute, let me see.
You go to questions tab and
Acha, now it is appearing. Yeah. What process to join as a researcher? I don't know.
no, those are old. You
No, no,
scroll by
right.
chronology.
No. I found this, which is a paper referenced by this. Okay. Yeah, this is what I had put it in the references here. Can you put the references? Yes.
Yeah, I'll put it
So
in the chat for all.
chat, okay, chat box also. That's no problem. Both these things you can see in the references, but I have tried to combine both of them. One is that actual, this one, the presentation part, which is energy part, and the other one is the paper referenced in that, which is again, I've put both of them here. So this is the context there. And my purpose of this whole talk was to try, and because I feel our people in the technology center are very, very strong. We have a lot of uh, API level and the algo level understanding and the knowledge of it. But I just wanted to give it another flavor where for productionizing it or application part of this technology, if we can use these kind of concepts to solve the problem, maybe we could be even better in creating more products. So that was my intent for this.
There are few more
Any
questions. Just
connection?
check.
Uh, can you give any connection between these two approaches and tuning NLG by Microsoft? I'm not sure. Can you put references? Okay. So this NLG by Microsoft, I'm not aware, because NLG is a huge field getting used in multiple options. So if we have this kind of technology, this was only for dialogues. It could be used for summarization. It could be used for any of the NLP sections that we want to have, especially where generation of text is required. We can do this. And some of them we can actually use even when the generation is not there. But uh, as a complete solution, I found that hierarchical this thing in uh, dialogue, strategic dialogue, the strategic dialogue application I thought was a very simple application, but a very important one. And we could use the strategy part of it in not only in dialogues, but on any of the other options also. And also the part where we're using reinforcement learning and deep learning together to solve problems could be used beyond NLP also, like we have done in some other this thing. Previously, that healthcare solution was also on a similar kind of play field.
Yeah, Salim, you keep finding these multimodal solutions, huh?
Yeah, I
So
love to solve, I want to bring solutions to the technology people. I mean, yeah, we love technology, we want to do it, but technology, the problem is it is changing all the time. But these concepts will remain with us to solve bigger problems and bigger, even across technologies. So this was my thought here. And any,
now let's say there
anything?
were three people negotiating on a deal. So I
Okay.
guess we have to bring in multi-agent RL then, huh? Three
Yes,
people.
yes. Yeah, yeah. See, this is basically this concept. What was there was basically to train that RL model because it is playing against itself, right? So it is taking care of all the options that are humanly there. And sometimes what happens is if you train it with a set of rules and all that, then it gets kind of constrained. Here, the agent is getting trained on options which are maybe human, maybe beyond that, maybe not too logical for that, and then come out with solutions. So it is a bigger, it is like AlphaGo kind of thing, where initially they tried to plan it with the best of the players. They thought that using that as their reference to make them play that and then play with the uh, players, then they created a subset of that. Then finally they said, no, let's just get two RL agents to play amongst themselves and get all the options that may not come to human beings as a possibility and then play. So this is one of those things, especially with strategy. Strategy, if you give it to humans, they are limited by what their playing field is and what their. But if you give it to RL with only ground rules and ground set of these things, they will come up with options which may not be used by humans at all. So I think that is where the this thing is going, and learning to learn is what the mantra is. It is not learning for learning a specific task. It is learning to learn a specific set of tasks in a specific area, and may not be the area could be anything. So this part where RL, I think the environment part is getting more and more extended.
So when we say negotiation and a deal
Mm-hmm.
closing, it's not just when we think about normal human negotiation, it's not just about
Mm-hmm.
negotiation. It can be any conversation, right?
Yes,
Yeah.
yeah, but here because you have to have a goal in place, right?
No, let's say I am talking to my daughter, and
Mm-hmm.
so it's just a beginning of our discussion and conclusion of the discussion. There isn't any negotiation per se happening. It's just a
So
conversation.
then why use this technology? I mean,
No,
you
no,
only
for
use technology.
if I am doing a chat bot, let's say I'm doing an inquiry with my bank, right?
Mm-hmm.
Please tell me my bank balance using a textual chat bot. So
Mm-hmm.
it isn't a negotiation. It's just an inquiry to check my bank balance using a text chat
So
bot.
that is much easy. Then you don't require such a lot of technology there. Then there's information you require, the information is received. So there is nothing. What happens usually is in uh, discussion, in negotiations, that things which you have not thought about come in.
I
So
see.
as
So more
long as,
dynamic dialogue. Okay,
yes, dynamic dialogue is the main thing.
I
And where
see.
you are looking at trying to close something, I mean, there's a transaction that needs to be closed. So if the transaction needs just a question and an answer, then you don't need such a involved technology at all. But if
But
the
what if question and answer is also dynamic? I mean, it will adapt based on the
yeah,
discussion
yeah, so
back and
that definitely you can do.
okay,
You can
okay,
use the
got it.
same model for that also. But there, in that case, you are not looking at closure. Because the strategic discussion should be such that the machine should win, right? So it is able to give you the option such that the other person is not able to. In this case, there were two machines, so it was just a training thing. But if it is a machine and a human being, and this, it's like playing against a human chess player or a go player. But if you are playing against two agents, then it's a different ball game altogether. If you're
Okay,
playing against a chess player and you have all the moves which are there, then you will win. And that's what is happening now. This AlphaGo is winning, I think, 60,000 to 1 or something like that. Because whenever the humans come up, they only have options that they play with. And this machine has multiple options, anyways.
okay. Any other questions from audience? So one question is there, but one side of negotiations should be machine.
Yeah, one side of, yeah, definitely. Otherwise, we don't need this, right?
Okay,
This is when you are maybe robo kind of things are negotiating on whether to bomb or unbomb uh, a place. Then maybe they can use this for the machine to tell the options to a human being that, okay, these are the options that you would have looked at, this is the option that you have not. So these kind of things also can
I
be used.
I use Amazon Alexa Echo device and also Google Assistant, the voice speaker.
Mm-hmm.
So when I ask it,
Oh, lost you. Hello, I lost.
Yeah, hi, Salim. Yeah,
Yeah, now
can
now I'm there.
can it be between humans and machines? I think you answered
Yes,
that there.
yes. I
Okay,
mean, one of the agent is a machine, the other one is a human. Why not?
right.
So
Okay,
this
audience,
actually
any
we'll
other?
go.
Sorry.
This we can go in the next level when we actually see the code.
Okay, so maybe we'll take a last question. Any other last question, audience? Okay, thanks, Salim. Excellent session. Very
Yeah,
interesting
I mean,
algorithm
this
in.
was just a new kind of type of session because I just wanted, like I said, my intent was basically to make people aware that the technology is what it can do and explicit details of how small things can be done, and then we can use the same concept to solve other problems in other domains also. Next time we'll go to the specific of this problem to give you the code walkthrough, and also the results that this paper has found. Overall, the result is that this is much better than what was been there before, and it is very close to how the human interactions happen for strategic dialogues. Okay?
Uh, okay,
Yeah.
okay.
So,
So thanks a lot, Salim. Excellent session, and
welcome.
thanks audience for joining. Very good session by Salim. Thanks once again.
Thanks a lot. Bye.